Okay, so let's do this. All right, so first up, all right, we are doing some sinusoidal word problems, so we'll at least get one of these word problems completed today. This is not actually a word problem. This is like a prelude to it. Okay, I just want to go through a little activity here with you for a few minutes before we actually start a word problem. And in this particular situation, okay, what we have is we have you're told that you have a sinusoidal function and you're given 2 points on the graph. If you're given a maximum and a minimum point, then you can sketch the entire graph. That's all you need, all right? You only need two different points to actually come up with the graph. Because if you have a max and a min, then it's going to alternate between those max and mins, and it's just going to continue to infinity and to negative infinity. So let's try to draw this graph given those two different points. So this is what I have right here, and it's up to yourself what kind of scale you want to draw for this. But if I look at the x values and I see numbers like 90 and 180, then I don't want to go by ones or fives. So I want to pick an appropriate scale for that. So why don't I say I go by 45s? That's just a suggestion. Okay, you can decide on yourself. But here, going by 45 seems to be a good idea, and that way I can get in a couple of waves of my graph. Okay, and for the y values, the lowest is -1 and the highest is +5. So it makes sense to go by ones. Okay, again, if you want to go by halves or twos, it's up to yourself. Okay, but going by ones here seems to make sense. And this is not a word problem, so we don't need to label the axes or anything. That's going to come up a little bit later. So right here, okay, let's plot the 2 points we have. We have a maximum point at 90 and 5. We have a point right here. And we have a minimum point at 180 and -1. So this means that the graph is going to alternate between those 2 points. So you might say, well, how do I draw a wavy graph when I only have 2 points? Well, the thing is if you have the max and min, okay, if you notice that the distance horizontally between the max and the min is 90 degrees, right? At 90, you have a max, at 180, you have a min, then you'll have another max at 270 and another min at 360. Okay, because it's going to stay consistent, right? So your waves are always going to be the same size. So you can keep going up and down by the same amount. And similarly, okay, we know that there's going to be even a minimum right here at 0. And then you can just try to construct your wavy graph from there. And here we go. We have designed a sinusoidal function when we only had 2 points. As long as those 2 points are consecutive max and min, then you can continue that pattern to infinity. You could even do more waves if you had room. So that's important because what's going to happen in the word problems is, in general, you're only going to be given a max and a min point. And you have to figure out the graph, and then you have to figure out the equation. And then you have to plug in a number and solve. These are going to take a little while to do, all right? But we're going to go through this slowly. And we're going to get to one example right now that's an actual word problem, meaning that you're going to have units of measure and all that sort of thing, okay? So what we're going to do is we're going to take a look at this problem right here. And I'll give you a moment to copy this down. We're going to take a look at a Ferris wheel. And Ferris wheels resemble sinusoidal functions. So I'll give you a moment to get that down, and I'll be right with you. Okay, so we're gonna get started. All right, and I was just doing attendance there, and it looks like everyone is here. Okay, so that's good news. All right, it looks like we have everybody on deck, so that's really good news once again. So thank you for attending these classes, and away we go. Okay, so Ferris wheel, how does this resemble a wavy sinusoidal function? Well, first of all, you might think, okay, well, isn't a Ferris wheel something like this? Isn't it a circle? Well, it is. The actual wheel is a circle, but your height is over time. Your height, okay, you're gonna get on the Ferris wheel at the very bottom, and then you're going to reach a maximum height as the wheel goes up, and then it's going to go take you down to the bottom again, and then you're going to spin around again, and so on until the ride is over. So over time, your height is going to increase and then decrease, and it is just going to keep going in that type of cycle. So that's what's happening with these word problems. All right, we're gonna just deal with Ferris wheels today. And what's going to happen is I'll say at this point that every one of your graphs that you have to draw is going to your x-axis is always going to be time. I don't think there's any exceptions to that. Okay, and just in general with word problems, with graphs, whether it's math or even physics, you're usually going to have an x-axis, an independent variable of time. Now, it's not always going to be seconds. It could be minutes or hours, but you're generally looking at things, how things change over time. So if you're ever confused about what should go on the x-axis, time is usually the answer. And I believe it's going to be for every single problem that we do. And height is a very common y-axis unit. So in this case, it's height in meters. And that sounds about right as well. Okay, and the reason why I'm using positive axis only for x is because we don't really deal with negative time. You could deal with a negative height if something was underground, but Ferris wheels are all above ground, so we're going to have positive heights as well. And the Ferris wheel, okay, it says that the wheel is 1.5 meters above the ground. That makes sense, okay? The wheel has you're probably familiar with Ferris wheels anyway, but you can't have the Ferris wheel touch the ground because if it's moving around uh, and the wheel is scraping the ground, you're going to have lots of sparks flying, and there's going to be kids screaming, and that's not how Ferris wheels work, right? They're a little bit above the ground. So in this case, they're 1.5 meters above the ground. So we can just say somewhere here is going to be our minimum value of 1.5. And I tried to keep this word problem as short as possible when it comes to the words in here, so you don't have to write too much down. But it should go without saying that when you begin on the Ferris wheel at time 0, you begin at the very bottom. You climb in, and then the wheel starts turning around. All right. So what's going to happen is it says a Ferris wheel rotates once every 36 seconds. What that means is you're going to start at the bottom, you're going to go all the way up, and then all the way back down every 36 seconds. So here, if I say at 36 seconds, the wheel is going to go up and then back down. And then another 36 seconds, it's going to do the same thing. Every 36 seconds, it's going to do that. You can even do more periods of that graph if you want, but it's really not necessary. Now, maybe yours is a little bit neater and it's on graph paper, I don't know. Mine is, it's a really rough sketch here, but it does the job. So every 36 seconds, you're going to go all the way up and then all the way down the Ferris wheel, starting at a minimum height of 1.5. What is the maximum height? Okay, the maximum height here, well, if the Ferris wheel has a radius of 25 meters, sometimes they give the radius, sometimes they give the diameter. The diameter is double the radius. So if the radius is 25, then the diameter is 50. So that means the distance between the bottom and the top is 50 meters. So in that case, okay, what we're going to have here is that if the space between the bottom and the top is 50, then the maximum height is going to be 51.5. Okay, because that's the distance between the bottom of the Ferris wheel to the top of the Ferris wheel. And so then we basically have a graph. And now what we need to do is we need to come up with the equation of this. And the equation of this graph is going to look something like this. Okay, so why don't we come up with a mapping notation first. And here, okay, I want to finish this problem. So I'm going to try to go through this a little bit quickly here, okay? But the middle of this is at 26.5. Now, again, that's a little harder to do, but if you get the average of your max and min, you add up 51.5 and 1.5, and you divide it by 2, you'll get the middle. So that is your sinusoidal axis, which is your vertical translation. The distance, the amplitude, the distance from the middle to the top is 25, and that is your amplitude or your vertical stretch. And from there, okay, what we need to do is we need to get the horizontal stretch and the horizontal translation. So let's figure out what the horizontal stretch is first. So you need to, once again, we have this formula that period is equal to 360 times horizontal stretch. The period of this graph is 36. Every 36 seconds, it goes all the way up and then all the way down. So the horizontal stretch is 36 divided by 360, which reduces to 1/10. So we can put 1/10 in for our horizontal stretch. Now, you can make a sine or cosine graph or equation. It doesn't really matter. Here, it seems like it's a better idea to do a cosine graph. Okay, if you did a sine, that's fine. But notice that the maximum point, what is the x value for that? Well, it has to be in between 0 and 36. So it's going to be an 18. Right, these are all consistent, so you know that the maximum has to be in between the two minimums. So it looks like it's shifted to the right 18 units, so we have a plus 18. And then what we have to do is we have to make an equation for this, which we just did in the review, and then we have to solve the problem. All right, so what I'm going to do is I'm going to take that mapping notation and I'm going to make an equation. We made an equation for cosine. So what you're going to have is you're going to have y is equal to 25 cosine, and we have plus 26.5. Those are the y values. And the x values, we have 1/10x, so we flip that over, and that's going to be 10. And then we have x plus 18, which is going to be x minus 18. And that is the equation of the graph. Now, we have to actually answer the question, and we're going to use the equation to answer the question, which once again, okay, when you're doing this, you're going to need your calculator. We're not going to use the unit circle, and you want to put your calculator in radians, or put it in degree mode for all the word problems. The reason why we're doing degrees is because when we did the period formula, we used 360, not 2 pi. So this is going to work for degrees because we decided to do 360. And in general, for all the word problems, we could do 360. All right, and just going to try to breeze through this as quickly as possible to get you out of here. And once again, we're going to work on these tomorrow and Monday as well. All right, so no concern yet. We're going to get practice on these in class tomorrow. I'll give you some time to work on some. But here, okay, what we have to do is, if you look at the question at the very end, it says calculate the height after 50 seconds. Now, 50 seconds is approximately right here. And we'd have no way of doing this with the graph other than an approximation, but we can assume that at 50 seconds, it's probably a height a little less than 51, like maybe 44 or 46 or something. Those are numbers that we would expect based on this rough graph that I have. So I'm going to put in 50 seconds is time, it's X. So what I'm going to do is I'm going to put in 50 for my X value. And then from there, the calculator does all the work, but you have to do the order of operations. So first up, okay, what we're going to do is we're going to focus on this inside part here. And even more specifically, I'm going to focus on simplifying that angle, cosine of what? So, and I'm going to do every single step here. You may want to skip some of these steps, but we're going to have cosine of 10 times 50 minus 18 is 32. And then 32 times 10 is 320. So all I did there is plug in 50 for X and then simplify that angle using the order of operations. Next up, okay, I have the cosine of 320. That's not on your unit circle. We're not using unit circle for these anyway. Okay, we're just going to plug into our calculator, make sure it's in degree mode. And what you're going to do is you're going to put in the cosine of 320 into your calculator in degree mode. And you should get approximately 0.7660. And then from there, okay, we're going to do times it by 25 and add 26.5, and we get 45.65 meters. And that's somewhere around what we predicted. Okay, we predicted, like looking back at here, we predicted that at 50, it's going to be a little bit below 51.5. An answer of 45, 46 or so seems appropriate for this. And of course, it is a word problem, so we want to express our height in meters. Now that's really quick. Okay, you're going to have time we're going to do another example together tomorrow. You're going to have time to work on one on your own. Okay, so we're going to take this slowly over the next few days. This is not an easy topic, even if we were in class. Okay, so if you're a little bit confused about things, well, that's probably normal at this point. Okay, but it is 12:15, so I'm just going to leave it at that. I'm going to let you go. And if you have any questions about this, let's wait until tomorrow and we'll work through some more problems in tomorrow's class. All right. Have a great day, everybody, and see you tomorrow.